This lesson is absolute value functions. So absolute value should be something you're familiar with, but it's probably been a while. So I'll review what that is, and then we're going to go a little bit deeper into it because this is Math 3. So our learning target is I can solve absolute value equations. Anytime you see the word solve or equations, you're going to be looking for numerical value. So what does x equal? So that's what we're going to be doing. So this is what it probably looked like in previous math courses. So absolute value is the distance from 0 on a number line. And it's always positive because distance is always positive. So when you had stuff like the absolute value of -3, it would equal 3 because the distance from 3 to 0 is 3. Or the distance from -3 to 0 is 3. So that brings us to our next thing. If we had an absolute value equation like this, we're saying the absolute value of x equals 3. However, since we're talking about distance and we don't know if that means from 0 to the right is 3 or from 0 to the left is 3. So see if you can see what I'm saying. The absolute value of -3 equals 3 because there's 3 units from -3 to 0. And the absolute value of +3 is 3 because there's 3 units from +3 to 0. So when you do a problem like this one, you would have x equals a +3 and x equals -3 because there are 2 values that have a distance of 3 from 0. Okay, so that's review. That's what absolute value means. Okay, and we're going to look at some absolute value functions. So, if you have a TI graphing calculator, you can get to the absolute value bars by going to Math, so the button that says Math, and then if you will right arrow over so that num is highlighted, and you can hit enter where it says ABS, and those absolute value bars will pop right up for you. You can also go to Desmos.com and you can type this in. You would just use the shift key and the little, I don't know, is it a backslash button? It's right above the enter button, but those are your absolute value bars, how you type them in. Okay, so I want you to pick one way to type this into a calculator, or remember that you can always make you a little table. So you can do x, y, and you can just choose some values. So I chose these values. I'm going to plug them in really quickly. -4 plus 2 is -2. The absolute value of -2 is 2. -3 plus 2 is -1. The absolute value of -1 is 1. -2 plus 2 is 0. Absolute value is 0. -1 plus 2 is 1. Absolute value of 1 is 1. 0 plus 2 is 2. Absolute value of 2 is 2. So now you have some coordinate points. You didn't even need a calculator. Go ahead and graph that. Alright, so if you'll notice, anytime we have absolute value graphs, these are V-shaped graphs. So if you don't see the V, you probably didn't use enough values of x. But that's pretty easy. I'm just going to erase this to give myself some more room. Okay, so the domain, remember, is your x values, how far left and right it goes. And we're going to do this in our interval notation. So notice that the left side of that V shape, it keeps going left forever. So it would actually start at -infinity. And it also keeps going right forever. So it would stop at infinity. And remember, you always put parentheses around infinity. Okay, so the domain is going to be from -infinity to infinity. The range, it definitely starts right here. Remember, that point is -2, 0. So the lowest y value it ever gets to is 0. And it can equal 0, so we're going to do bracket 0. And then this graph will continue going up and up and up forever. So it goes all the way to infinity. And that's how we do that. Okay, the vertex is the very middle of the graph, and that is at, well, let me do a different color. We've already listed it here, -2, 0. Alright, so that's how every time absolute value graphs are going to look, the domain is always going to be from negative infinity to infinity. The range will change a little bit, and the vertex will change. So now let's look at solving absolute value equations, and this should be new information for everyone, unless you had a really good math teacher who went beyond what they should have. Okay, anyways, so there's 3 steps that we're always going to do. Number 1, we're going to isolate the absolute value bars. We're going to get them by themselves. After we isolate, if the problem equals a negative answer, the answer is no solution. Because, remember, distance can only be positive. So if you get those absolute value bars by themselves and they equal negative, that can't happen because distance cannot be negative. Okay, number 2, we're going to make 2 equations. We're going to set the value between the bars equal to a positive and negative number. That goes back to this example. When we did this, the absolute value of x equals 3 had a positive and a negative value because you can go to the left of 0 and to the right. And then the last thing we're going to do is solve both equations. So the first thing that we want to get rid of, we want to get the absolute value bars isolated. We need to get rid of this minus 5 first. How do you get rid of a minus 5? You add it to the other side. So here's what we have left. Okay, I want to caution you at this point. Some people think it looks like this. So normally when we had a parenthesis, we would distribute. We do not have parentheses, do not distribute. The 3 and the absolute value bars are being multiplied. The way you get rid of multiplication is to divide. So we're going to divide both sides by 3. So now we have the absolute value of 2x plus 3 equals 3. Okay, so we have done the first step. It is isolated. The problem equals a positive answer, meaning that we can go further. All right, so now step 2, we're going to make 2 equations. We're going to set the value between the bars, the 2x plus 3, equal to a positive and a negative value. So it's going to equal positive and negative 3. Whatever number was right here is going to be your positive and negative value. Also notice that I have dropped the absolute value bars. That's because I've made 2 different equations. We don't need them because we have a positive and a negative. We have the left side and right side of the equals. Check. All right, I'm going to clean this up a little bit just so I can have some more room. Okay. The last step I'm going to do in blue, we're going to solve both equations. So the first thing we want to get rid of is this plus 3. The way I get rid of a plus 3 is to subtract both sides by 3. Oh, that was embarrassing. That's a 0. I'm going to do the same thing with this side. I'm going to get rid of this plus 3 by subtracting. And then the last thing I'm going to do is I need to get rid of this 2. Since the 2 and the x are being multiplied, I'm going to get rid of multiplication by dividing. So anything, 0 divided by anything is 0. Same thing with this side. Negative 6 divided by 2 is 3. I have 2 different answers because whenever you think about a number line, you can go to the left of 0 and to the right of 0. That's why you're usually going to have 2 answers when you do this. Okay, I'm going to do the same thing for this one. Number 1, we're going to isolate the absolute value bars. So I'm going to get rid of the minus 9 first. So notice anything that's being subtracted or added after the absolute value bars, I get rid of first. Okay, and the way we get rid of subtraction is addition. So I'm going to add that and I get 63. The next thing I'm going to do is I'm going to get rid of the 6. The 6 and the absolute value bars are being multiplied, so I'm going to get rid of it by dividing. And you could put 10.5, or if you like numbers or fractions, you could do 21 over 2. Same thing, whatever you want to do. So step 1, check. The answer equals a positive number, so it's not going to be no solution. We're going to go further. Next, I'm going to make 2 different equations. So I'm going to take the value between the bars, 1 minus 5x, and I'm going to set it equal to this positive and negative answer. Okay, and I drop the absolute value bars whenever I make the 2 equations. so check. Alright, I'm going to need some room, so I'm going to erase the top part. Okay, and the last step is we're going to solve both equations. So the first thing I need to get rid of is this positive 1. So because it's positive, I'm going to subtract both sides by 1. Same thing with this one. I need to get rid of the positive 1, so I'm going to subtract both sides by 1. The next thing I need to get rid of is the negative 5. And since the negative 5 and x are being multiplied, I'm going to divide both sides by negative 5. I never expect you to do stuff like this in your head. You'll probably hear my little calculator clicking. Go ahead. Use your calculator. You get to use it the whole time in this class. Next thing, I'm going to get rid of this negative 5. I'm going to do the same thing. I'm going to divide both sides by 5. I got 2.3. So we had two different answers. That makes sense because when we talk about absolute value, you can go to the left and to the right. Alright, I want you to try this one. So I want you to pause this screen and then unpause when you feel like you have gotten the answer right or if you get stuck. Okay, so first thing we're going to do is we're going to get rid of this 2. So some people like to do 2 minus 5 is 3. That's not how that works. We're going to get rid of the 2 by subtracting it from both sides. Okay, and now I'm going to get rid of that negative 5 by dividing both sides by negative 5. Alright, I get 15, so check one. Alright, then I'm going to set this into two different equations. It's going to equal a positive 15 and a negative 15. Okay. And then I'm going to solve both equations. So I'm going to get rid of that minus 5 by adding, and I'm going to get rid of the 5 by dividing. The next one, I'm going to get rid of the minus 5 by adding, and I'm going to get rid of the 5 by dividing. So, still I got two answers. Makes sense because we're talking about absolute value. Just the first part, if you did 2 minus 5 equals 3, that's something that people do. Just get used to that. Just know that that is like two different things going on. Alright, let's move on. Alright, this one's even easier. So, go ahead and pause it and you try it. Alright, so the first thing you should have done was isolate the absolute value bars. Okay, and then you should have made two different equations. And remember, when you make the two different equations, you get rid of the absolute value bars. And then the last thing that you do is solve. So this one's pretty easy. So hopefully you got that right. If you didn't, it's okay. We're still learning. And there's my two answers. Okay, now let's come on to this thing. I'm going to try to color code it because I think it helps. But we're going to talk about absolute value inequality word problems. They look a whole lot scarier than they are. I promise they're not. So this is what it looks like. You're going to have absolute value bars. This can be any variable. It's whatever you're talking about in the problem. Any variable. This next part over here, that's a number. That's your desired value. That's like what you want the average to be. You're always going to have this minus sign. It's never going to be a plus. If you ever see plus in the answer choices, mark those out. That's not it. This is always going to be less than or greater than. Less than or equal to. If it's a greater than sign, mark those answer choices out. That's not it. And then this is called the tolerance value. It's like how far below or above the average you would be okay with. Okay, so that might be a little confusing. Let's look at this. Oh, one more thing. The big number is always going to be right here. The small number always goes right here. Alright, and I'll show you what I'm talking about. So let's talk about pants. I did women's pants just because I'm a woman, so I knew how to give this information. But if you go to a store, like Old Navy is like the worst for this. I have to try on like 10 pairs of pants, the same size. Some of them be way too big, some of them are way too small. And that's because you have a tolerance level that you'll do. So when somebody's sewing pants, if you look at this chart, a medium is like a size 10, but the waist is supposed to be a 30.5. If it goes up to a 32, they call that a large. If it goes up to 33.5, they call that an extra large. But what if your waist size is a 31? Are you a medium or a large? And you just don't know until you try on the pants. So we're going to write an inequality for waist sizes that should be considered large. So here's what we're going to do. I'm going to do X. X is going to stand for waist sizes. I'm going to do a minus sign because it's always a minus sign. The next one should be like what I want it to be. So I definitely want the waist size to be a 32, less than or equal to. However, notice how much will you let it go above 32? You'll let it go 1.5 more, and you'll let it go down 1.5. So that's your tolerance level. So let's see if that makes sense. So if you're a 30.6, you could be a large, and you could go all the way to like 33.4. So this is a big range of values that would be a size large. And that is why you have to try on your pants when you go in a store. Because you could be a size 31 and fit in large, or the manufacturer could have been a 32 and they would have put a large on there. So that's just a range of values. Okay, so we're going to look at these. The arrival of an airline flight was predicted to be within 5 minutes of the scheduled flight of 120 minutes. So that means that it could have taken 125 minutes or it could have taken 115 minutes. If the flight did not arrive in time, what was the airline's actual flight time? And we're just going to worry about writing this inequality statement. So here's what we do. It's going to be X minus. You want the value that you want to happen. So you want the scheduled flight to be 120 minutes, less than or equal to, but it needs to be within 5 minutes. So that's your tolerance. Or, this is what I was saying before, always put the big number from the problem right here and put the small number right here. Always make sure there is a minus sign and make sure it's less than or equal to, and you good. All right, I want you to try the next one. So pause the screen and you try it, and then play when you're ready. A survey by a marketing research company shows that 56% of customers polled prefer Cola A over all other soft drinks. The survey has a margin of error of 13%. What percent of all soft drink users prefer Cola A? So we're going to write an inequality statement. X minus, always a minus sign. You don't even have to think about this. Put the big number right here. Less than or equal to, put the small number outside. That means you want the research to be 56%. However, you have a margin of error. So you're willing to go above 13% of that 56 or below 13% of that. Alright, so I want you to see what a problem looks like that was on the released EOC. A company makes and boxes spaghetti. Whatever. A machine fills each box with approximately 32 ounces. So you want the machine to be 32 ounces. You want the machine to fill the box 32 ounces. After the boxes are filled, another machine weighs each box. A box is discarded if the weight of the box differs by more than 0.25. Which inequality can be used to find the range of acceptable weights X of the spaghetti? Okay, so remember what I said in this video. If you see a plus sign, it is not that. If you had seen a greater than sign, you could have marked that out. And then also, you know that it's got to be C because the bigger number is inside the absolute value and the smaller number is outside. This is what you want your target weight to be. You want it to be 32, but this is your tolerance. You're willing to let it go 0.25 above or 0.25 below. So that's what absolute value inequalities look like. They're pretty easy. And then you need to make sure you understand how to solve an absolute value equation. You're probably going to get two answers. You can get only one answer, and you can get no solution. And then remember that anytime you talk about the graphs, they need to be V-shaped. The domain is always going to be from negative infinity to infinity. The range and vertex will change. And just remember, the absolute value is the distance from 0, and because you're talking about to the left and to the right, you're going to have two different answers. And remember that distance is always positive. All right, hopefully that made sense. If not, contact me. Bye.